Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of differential equations. And if I talk about the question that is given to us here from this topic, the question tells us that if a curve y equals y of x, which is there, it passes through the point 1 comma pi over 2, and it satisfies a differential equation which is given to us as 7x raised to 4 cot y minus e raised to x cosec y, and that is equal to, that is multiplied with dx over dy, and that is equal to x raised to power 5, where it says x can be anything but greater than or equal to 1. Then the question is asking me at x equals to 2, what will be the value of cos y? So that's the question asked to us. Let's try to figure out how to solve this question further and find the value of cos y. And if I talk about the answer choices that they have given to us, it says 2e square plus e over 64. Option B, it says 2e square minus e over 64. Option C, 2e square minus e over 128. And the last answer choice I have here, it says 2e square plus e over 128. So we need to figure out which one of the answer choices is the correct answer for the question that is asked to us, that asks us to find the value of cos y. Let's see how to solve this question further. Before starting off with the solution for this question, I'd first like to tell you that if you're enjoying these videos that we are doing, please do like the videos, do share this with your friends also who are involved in the preparation of questions on JEE. Let's see how to solve this question further now. So I have been given a differential equation which says 7x raised to 4 cot y minus e raised to x cosec y, and that was multiplied with dx over dy is equals to 5. So if I take first dx over dy on the other side, it will basically make it 5 dy over dx. So basically it is x raised to 5. So it will go with this x raised to 5, and that will make it x raised to 5 dy over dx is equal to the whole thing 7x raised to 4 cot y minus e raised to x cosec y. Now if I try to write it in the form dy by dx minus plus py equals q, let's try to do that. So what I can do is I can write cot y as 7x raised to 4 cos y over sin y, and minus e raised to x cosec y I can write as 1 over sin y, and x raised to 5 divided by dx as it is. Now everywhere I see I have a denominator of sin y, so I'll multiply throughout this whole equation with sin y. So what do I get here is x raised to 5 sin y dy by dx is equal to 7x raised to 4 cos y, because this sin y gets cancelled with this sin y, minus e raised to x, this sin y also gets cancelled with this sin y. Now I have it in the form here. Now further, if I try to write it, I don't want this x raised to 5 here. So what I will do is everywhere I will divide by x raised to 5. So here I'll divide by x raised to 5, here also, here also. So what I get from here now, sin y dy by dx is equal to, this x raised to 4 cancels with this x raised to 4, so 1 is left, so I get 7 over x cos y minus e raised to x over x raised to 5. Now what I can do is I can see sin y and cos y is present. So what I can do is I can put sin y as substituting any other variable. So let's say I put sin y as t. So what happens is cos y dy by dx basically becomes dt over dx. But I have sin y with dy over dx, not cos y with dy over dx. So we should not substitute sin y as t. We should do the opposite. So let's do cos y is t. So if I put cos y as t now, what I can get from here is minus sin y dy by dx is basically dt over dx. So I get from here this. So I can write sin y dy by dx as minus dt over dx. So I get this. Now once I get sin y dy by dx is basically minus dt over dx, let's put it here. So I get my differential equation minus dt over dx is 7 over x cos y, I put it as t, minus e raised to x over x raised to 5. So I have it in the form now. So now if we rearrange this into our general form, which is basically in the form dy over dx plus py equals q. So I'll take my dy over dx and the y term on one side and the constant term on the other side. So if I do that here, I can write this as minus dt over dx plus 7 over xt on the other side comes here, becomes minus 7 over xt is equal to, I get minus e raised to x over x raised to 5. Now, everywhere, because there is a minus sign present, I can just multiply everything with minus 1 and that would make it dt over dx plus 7 over xt is equal to e raised to x over x raised to 5. So I get this. Now, if I compare it with this, instead of y, we have a t here. So p with this comparison of the general form becomes 7 over x and q becomes e raised to x over x raised to 5. So we know whenever we have it in this form of dy by dx plus py equals q, integrating factor becomes e raised to integral p dx, which in this case is e raised to integral p is 7 over x, so 7 over x dx, which makes it e raised to 7 out. Integral of 1 over x is natural log of x. So that makes it e raised to natural log of x raised to 7. And e raised to natural log of the function is nothing but the function. So basically it's x raised to 7. So I get my integrating factor turning out to become x raised to 7. Now once I have that, I have to just find the solution of differential equation, which is basically given to us as y into integrating factor is equal to integral of q into if into dx plus c. So we have this as my solution, but instead of y here, we have t here. So instead of solution of this general form, I would write t. Integrating factor is x raised to 7 is equal to integral of q. Q in this case, we know it is e raised to x over x raised to 5. Integrating factor is x raised to 7 dx plus c. So I get this here. Now x raised to 5 cancels with x raised to 7, making it x squared. And t, I can just replace it. So t, we know it is nothing but what we substituted, which is cos y. So that leaves you cos y x raised to 7 is equal to integral of e raised to x into x squared dx plus c. So now what I get from here is u into v rule, that is your product rule. And we know product rule is integral u into v. So u integral v minus a big integral derivative of u integral of v. And further integrating it with respect to v. So that's my answer. So let's do that. First, let's integrate this. Whatever we get the answer, we'll just substitute in this solution of the differential equation. So I'll integrate this first separately, integral of e raised to x into x square. I go about the rule which is isolate. So basically what I get from here is exponential functions comes at the end. First comes x square, which is algebraic function. So algebraic becomes u and this becomes v. So this is u, this is v. So what I get from here is write u as it is, take integral of v minus a big integral derivative of u, which is just 2x, integral of v again, which is e raised to x. So what I get from here is x square. Integral of e raised to x is just e raised to x as it is, minus integral of 2x and integral of e raised to x is again e raised to x. So what I get from here is x square e raised to x minus 2, a big integral x into e raised to x. So what I get from here is again use the product rule, x square e raised to x minus 2. Now from here what you get, this is u, again this is v. So what do I get? U integral v, so x integral e raised to x minus big integral derivative of x, which is 1, and integral of e raised to x, which is e raised to x. So what I get from here, let's see. So x square e raised to x minus 2 x integral of e raised to x is e raised to x minus integral of e raised to x, which is also e raised to x here. So what do I get from here? Let's see. So x square e raised to x minus 2x e raised to x minus minus plus 2 e raised to x. So I get from here e raised to x is common. That leaves you with x square minus 2x plus 2. So that is the answer for the integral of the product rule that they have asked us to figure out. We got the answer for this integral. So my solution of the differential equation becomes cos y x raised to 7. So cos y x raised to 7 is equal to the integral of this whole thing becomes e raised to x square minus 2x plus 2 plus c. So I get this whole thing as a solution of my differential equation. Once I get the solution of this differential equation, now further, the question is asking me to figure out the value of cos y if this passes through the point 1 comma pi over 2. So we have to find the value of cos y at x equals to 2. So first, let's try to find the constant of the differential equation by putting x as 1 and y as pi over 2. So if I do that, in this I get cos pi over 2 into x raised to 7, so basically 1 raised to 7 is equal to e raised to x means e raised to 1, and here x square minus 2x plus 2, so 1 square minus 2 into 1 plus 2 plus c. So what do I get from here? Cos pi over 2, which is nothing but 0. 0 times anything is 0. E 1 plus 2, which is 3, minus 2, which is 1. So what do I get from here is c becomes e times 1, so minus e. So constant of the differential equation becomes minus e here. Once I get that, so my solution of the differential equation becomes cos y x raised to 7 is equals to e raised to x square minus 2x plus 2 and plus c in this case is minus e. So I get from here the solution of this differential equation. Once I get the solution of this differential equation, I have to just find the value of cos y when x is 2. So let's put that. So let's put just cos, let's just put x as 2, so I get the value of cos y. So cos y 2 power 7 is equals to e raised to 2, 2 squared minus 2 times 2 plus 2 minus e. So what do I get from here? Let's see. So cos y 2 raised to 7. So 2 raised to 5 is 32. 2 raised to 6 is 64. 2 raised to 7 becomes 128 is equal to e square. So 4 plus 2, 6. 6 minus 4 is 2. So I get e square times 2 minus e. So I get from here cos y is 2e square minus e over 128. So I get the answer to this question, and basically that matches with which answer choice. So it gets 2e square minus e over 128. That matches with answer choice C. So C becomes the answer for the question that is asked to us here. I hope you have understood how to solve this type of questions which deals with the ideas of using the concepts of differential equations. I'll again see you in another video with another question from another topic, but we are going to continue these questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well. Do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions that we are solving. Thank you.